documents for visually impaired. So a couple of things to, so we just, I just posted a questionnaire link on the chat. You can do it from there. I will also email to you after the class. So this questionnaire gets some information about what type of systems you're using, what's your familiarity and things like that. This will help us in getting a profile of our participants, as Volker is planning to do a fair amount of hands-on exercises. So this will help us in that also. That is one announcement. Second announcement is that we plan to create a sort of a document, a manuscript out of these lectures. So I will be posting again a link, and I would request that two of you participants can join and take up one of the lectures for transcription. So basically the way it's expected is that you will anyway would have listened to the lecture, then go to the video and you can listen again, look at some of the background material and try to produce a document. We are looking at around 6 to 10 pages for each lecture, which contains the material. Okay, so readable material which can be used as a add-on to these lectures. So we would of course edit it. We will write it up and do it, try to bring it in a certain uniform form. But we would like to get the first draft from the participants. Those students who are doing it on credit would also, this will also apply as some weightage for the credit, towards their credit for this particular course. So that is the second announcement. So please respond again, both to this questionnaire as well as to participating in preparing the manuscript. And we will, of course, we will acknowledge the people's manuscripts which come to a level where we can accept it as part of our documentation. Okay, so this will help the other students who are today not able to attend, participants who are not able to attend this course, but they will have both the video lectures and this document available. So wherever hands-on exercises are there, I would like that some hints are given to the participants to how do we go about doing that in terms of links and things like that. That should be included as part of the mass. Thank you. Volker, now this one is to you.
Right. Yes. So, as Paula's pointed out, we've got the questionnaire. If you want to read along with the slides, I've made them available now this time as well on GitHub. So the GitHub repository is at, it's called sorkov.github.io COV885. So COV is the 885 is the course number. And so you can just go there and you should see exactly the same view I have. And then you can just click along. Everything is replicated there. And obviously those slides will change when more things become available. And particularly these initial slides will change as the syllabus becomes more worked out. The single elements of the lecture will become more worked out. Right, so what I want to do today is I want to change it up a bit. So first of all, last time we decided, or I decided rather, after the lecture, after talking for 1.5 hours non-stop, my voice was nearly gone. So I thought maybe it might be a good idea to let you do some work today. So that's the first thing we're going to do, in particular in the second part of the lecture. And the other thing is that I will occasionally stop and just check whether you have any questions. And I will also, I'm intending to stick around for about 10 to 15 minutes after the lecture on this Teams channel, just in case you have any questions, you want to talk to me in person. So think about it as kind of the walk back from the lecture theater to the office when when you can accompany somebody and have a chat on the way. And that's what we're trying to do virtually after the lecture this time. Right. So in case you've managed to get to the slides, you can just jump to the next one, which is the continuation of what we've done last week, and last week, yeah, Wednesday. It's still the same week, I think. Yes. Right. So what we've done last Wednesday was I've given you a kind of a general introduction what usability means in the sense of what a usability software or usable design is. So it should be safe, it should be effective, it should be efficient, and it should be enjoyable. Those were the main takeaways, right? So it should be, you should be able to do something without hurting yourself while achieving your goal in a way that doesn't take you forever and that might leave you with a good feeling afterwards. That's the whole idea of usability. And for this, I've introduced the idea of universal design. And what universal design means is just that, you know, we design something that's not just usable for some people, or kind of for the mainstream, if you like, but it's usable by all people, even people that are kind of, you know, might have special needs, which then effectively comprises accessibility. So in many ways, we've defined accessibility as a usability for all, regardless of their special needs. And then I started introducing the web, and I showed you a bit in what ways the web is a throwback. Then we're now back into kind of the old parchment style, thinking about scrolling and vertically adding things at the bottom rather than to the right, as we would have in a printed document. But then we can also replicate effectively everything we can do in print, we can replicate on the web, and we can do so much more. And that's where we're going to step in today, when we're going to talk about, well, first of all, what does the web and accessibility really mean? How can we define these concepts of usability and accessibility more precisely for the web? And then we want to revisit in many ways the separation of concerns. I will tell you a bit about the full web stack, what's available to us, and then how we can employ it in order to make things accessible. And then we're going to see also how we're going to evaluate that. And that's where the interactive part will come in. So I'm trying to get through my first, I think, 15, 20 slides before the break. Then during the break, I will ask you to install a couple of things on your respective browser. And afterwards, we're going to work with that. And we're going to have a look at a couple of exercises. Now, there's my first question. Is anybody in the audience not using a WebKit-based browser? Or to put it more precisely, is any one of you still using an Internet Explorer, or is anybody using a Firefox?
I think Jared.
I'm using
Somebody's
Firefox.
Jared's raising. Yes. What are you using at the moment?
Firefox.
You're using Firefox. Do you have a possibility to switch to Chrome or to Brave or Edge?
I'll install Brave, sir.
Good, Brave is fine. Well, but you have to only at the break. And if you have any problems, feel free to ask again.
Oh, yes.
All right. But as I said, that's after the break. Right now, I'm still going to do some bit of quite a bit of talking before we actually get to that part. Right. So first of all, we've discussed last time, we've discussed usability and accessibility. Now we discuss it in a more precise way in order to apply it to the web. What is the usability of web design? And there's a couple of ways how to define that. Obviously, one I quite like is given by Nielsen's. Nielsen's is a company that does a lot of quality control components for web and web design and web accessibility as well. And the way they define usability of a website is primarily by, first of all, learnability is very important. What does that mean? That means, well, if I give you a website, if I give you an app, if I give you a web document, how easy is it for you to actually do something with it? If it's just obviously a page to read, that's fairly simple, but most of the time you have to perform some tasks. You have to at least go from one section to the other, even if it's a document. How easy is that to do? And then the second part is always how quickly can you actually do that? How long does it take you to find out which buttons to click in order to do what you need to do? And that's kind of the efficiency. Important with that is another one is kind of the errors. You do not you do not want your user to be able to make too many errors. In particular, if they make errors, how difficult is it to come back from those? That's a common phenomenon that that web designers, as well as programmers and developers, as well as us who design content for the web, often underestimate that you might have some path through your website, through your document, from which you simply can't come back, or you can only come back when you have to press the back button a lot, which is generally not a good idea. So in many ways, you always think about reading as a flowing action. You want to switch. If you're reading a book, you just want to go from one page to the other. You don't always want to constantly have to go to the index, find something in the index, and then find the right page again where you have to carry on reading. That is a very unpleasant experience. In many ways, we're trying to replicate something very similar for the web, something that gives you a natural flow from one page to the other, from one section to the other, without constantly having to go back to some homepage where you have to click again for another section. Once you've achieved kind of these three good tasks, the next thing is, of course, how happy are people actually doing this? How pleasant is it for people to use the page? Or how pleasant is it for people to use your particular piece of application or your software? That is particularly important these days, where there's an easy shift from one to the other. So think about the olden days, say the 90s, early 2000s, where most people were working with one particular operating system, and they were working with one particular office suite. We all know which one that is. And they didn't really have much in way of choice. And whatever developers at Microsoft thought they can foist upon people, they would just have to deal with it. Nowadays, that's different, right? You go to a web app. If you don't like it, you just delete it after 5 minutes and you get a similar one, which might be a lot better. So in many ways, this is a very, very important point nowadays. Satisfaction. How good are you in retaining people with your design? And the final one, which is here on the third point, is actually memorability. If you've done all this once, and if you're happy with everything, and you're now stop using something for a couple of months, and you're coming back, how hard is it for you to restart learning something? Do you need to go through the whole process again, or is it easy and comfortable for you just to pick up where you've left off and can restart your task? Right, so this is kind of the general idea of web usability. Then if we now narrow it down to accessibility, then obviously what we are primarily interested in here are three parts of the accessibility landscape in this particular course. We are interested in visual disabilities primarily. So how can we make sure that people with blindness or low vision, as well as with distracted vision, can work with our web documents, or documents in general? What if they cannot necessarily move everything, cannot use a mouse in particular, have other motor skill impairments which will not allow them to use every input device that is available? And also, what if they have some cognitive disabilities like dyslexia, dyscalculia? How can we support anything like that? I will, at some point later in the lecture, I will also probably towards the penultimate lecture, I will touch briefly on the area of oral disabilities. How can you support deaf or hard of hearing students or readers, particular these days where lectures are online, subtitles must be generated. How could we possibly do that for hard subjects like STEM and scientific or mathematical subjects? Right, and throughout we should always think about the following mantra. And I've written that at the very bottom of this slide. The web is accessible by default. If it's not, then we have done something wrong. In principle, all the tooling is there that allows us to make the web accessible. If we don't use them right, then it's broken. Right, and that is the question, of course, well, how do we actually define accessibility for the web then? And I'm sure some of you are familiar with some of the guidelines I'll show you now over the next couple of slides. And those are the web accessibility guidelines, the web content accessibility guidelines to be precise, or as most people call it in short, WCAG. So WCAG is being done by a number of primarily W3C consortium groups. I'm an invited expert on one of them officially. I never really attend the meetings, I have to admit, and that's the ARIA working group, but there's a bunch of others as well. And WCAG is the legal basis of in most countries for accessibility guidelines, and therefore it's quite important that people understand how it works. Unfortunately, the way they are written is not necessarily straightforward. So I've put together, here's the link to the actual guidelines. Let's just have a quick look. They're long, and there are many, and they're difficult to parse, and they're difficult to read. As a consequence, there's a number of documents which actually explain how to interpret them. Or also, here's a particular good one, which is a quick reference guide for the WCAG principles, which is something effectively a tick list where you can go through the list, you can tick the boxes and say, well, does that work, does that not work? And you can see here, if you can see the screen, there's 3 different levels effectively for WCAG. One is level A, which is just basic principle accessibility, which should always be guaranteed. Then there's a level AA. Level AA is what is law in most countries in order not to discriminate against people with special needs. These are the guidelines which should all be adhered to when designing a website or when designing a web document. And then finally, there's level AA, which is kind of advanced material, optional or ideal, but often, unfortunately, often disregarded, but it's very, very important. Some of those options are very important too. So WCAG is based primarily on four principles, and those are called the pour principle. Pour is in French for somebody. And the idea of those principles is that it's a process for people, that it works for the users that are affected by but where they are affected by inaccessible websites. So they are effectively helped by accessible websites. And what PUR stands for is 4 words. Obviously, it's perceivable, operable, understandable, and robust. What does that really mean? Well, we'll go through some of these examples, and we'll go through some of these points, and I'll tell you, and also as well as give you some of these examples in more detail. So perceivable, what does perceivable really mean? Well, first point of perceivability is, for instance, text alternatives. If there is something on websites which is not perceivable easily, then it has to have some sort of a text alternative. If you think about, well, the classic example, if there's an image on the website and you can't see the website, and your screen reader has to have something which actually tells you what is in that image. That is, of course, not always easy, because just adding an alt text to an image is not necessarily enough. How can we do, for instance, with something which has more content as can be described by text, where the content is really important to the extent that 160 characters, which normally are allowed for alt text, are not enough. And then another classic example of where this perceivability often breaks down is, well, what about mathematical equations? Are they being considered as kind of a graphic element that has to be described with text, or do they have to be described in some other way? And then where do we draw the line? How difficult does an expression has to become in order to be able to be described, or to be necessary, so it's necessary for this to describe it? And another important part of perceivability is also the adaptability of content, where you have to. So last time, if you've been to the lecture last Wednesday, I've showed you a couple of examples where a website in particular adapted itself to the particular form factor where it's being displayed, where it's still important that you can perceive all the information that's on the website, regardless of whether you look at something through your browser on your desktop or on your rather much smaller phone screen. And that's still things like there's a meaningful sequence of elements in the page which allow you to understand what the actual content is. And doesn't matter how you orient your website and how you orient the web content, is it still legible? Can you still understand what's going on? And another important part for perceivability is distinguishable. Is it distinguishable? And that generally means, does it support people who cannot easily distinguish between colors? If you use, for instance, different colors, is it difficult for people to see if they have, for instance, if they have a visual impairment, which kind of they're colorblind, or they have a partial blindness, etc. Is there some way of adding contrast? Is the contrast high enough? Can all the text be clearly perceived with respect to the background? Is anything hidden in images? If it is hidden in images, is the text still readable even if you cannot perceive the image? These kind of things are important parts. Reflow is an important bit where you have to think about, is something perceivable if I'm on a small form factor, or do I have to go very far to the right, or is things being cut off if I'm not paying attention? So if you have, for instance, a very static website, if you have a static document, think about you trying to display say an A4 web page on an A6 or A5 display, say of the size of a tablet or of the size of a phone. Do I have to pan around a lot? On the other side, will it adapt to the degree that I can see everything? However, it's so tiny that I can't read it anymore. So there's trade-offs where you have to say, okay, well, at least has to be some way of getting to the entire content of your document without having to without either excluding some people who can't see in a particular size, or excluding some of the document. Right. And since we're in the context of color, I'll show you a couple of things now. I'll show you an example which should demonstrate nicely what the problems with color is. Now, I'm aware that not everybody can see the screen I'll show you, but for those of you who can't, I'll try to explain as much as possible as what's on the screen. So we're looking at an image or a diagram of a function at the moment, and it is of a fairly straightforward curve. I think it's a cubic curve, and it's a function, and the image is stolen from the Wikipedia page on functions. So let me just go there. There's the Wikipedia page, there's the image, and the way the image is given on that Wikipedia page is via a bitmap image. What is a bitmap image? A bitmap image is effectively an image like a PNG or JPEG or a GIF, which you're probably used to from your cameras or from your mobile phones, which the idea of a bitmap image is effectively it's a rectangle, and each pixel has a certain value which gives it, or sometimes 3 or 4 values, which gives it a color and as well as an opacity. However, there's no relationship ever defined between the separate images. Now, what the problem with these images is that they don't scale very well. And for those who can see, I'll demonstrate that. If I just zoom in, you can see they become very grainy, and oops, that was not intended. Sorry. they become very grainy, and all of a sudden you can hardly make out the numbers. They become very obscure. Another problem with these images is that's the right size. Then they tend to the colors are fairly fixed. So here's an example I'll show you now that of the graph is given in a red line. The x-axis is given a blue line. The y-axis is given in a yellow line, and the actual coordinate system is kind of in a gray shade in the background, which should kind of underlay the entire graph. Now, already for me, with relatively good eyesight, it is pretty impossible. So the background of my slides is white, but it's pretty impossible for me to make out what the y-axis or where the y-axis is exactly, because the yellow and the white is a very poor contrast. So let me change the contrast for you. And the way I normally do this is, and let me show you my browser. I have this little high contrast app in the top, and you can switch it on with Shift F11. And what you then get is you get a much better contrast on the entire slide, but you don't get anything for the image. The problem with the image is it is a bitmap image, as I said, so all the colors of the image are defined a priori, meaning that everything is just it stays white, or in that case, everything white becomes yellow, and therefore it doesn't make any change. As a matter of fact, it becomes a lot worse in terms of contrast. So I can see even less is what I could see before. I switch up the contrast. Oops, sorry, that's my Firefox opening up. That's not intended. Here you go. Shift F11, and I'll switch it off. Let's have a look at a different example. Now the same function is here, but this time it's as an SVG image. So an SVG is part of the web specification. SVG stands for Scalable Vector Graphics. What the important part there is that everything in a way there is now given in terms of relations between elements. That means I can now draw a line by just saying, well, draw a line from here to there, as well as write a character somewhere. As you can see, when I zoom in, everything now stays nice and crisp. I can easily read the 0.8 here, which previously I couldn't really make out that well anymore. Another effect is that if I now change my contrast, let me do that. It doesn't change anything, unfortunately, because that's still a bad example, because it still has a white background here. And it still has the wrong colors there, right? Let me try to find a different way. Maybe I can get I can find a grayscale. Inverted colors. Inverted colors. Now that's better, right? That's much nicer on SVG. At least I can now make out the x-axis much better, and I can make out the y-axis, or the other way around, sorry, as well as the curve. Now my question here to you is, what's still wrong in that picture? What problem do you see on that page? Let me switch off the high contrasts again. And for those of you, particularly for those of you who can't see the picture, I'll read the caption to you. And the caption says, the red curve is the graph of a function because any vertical line has exactly one crossing point with the curve. Any takers? If you're still a bit hesitating what's wrong with that picture here, I'll switch on the high contrast extension again.
See, axis doesn't have any labels. Like
the axes have labels. So you've got tick points 1.4, 1.2, 1, and so on.
What does
What's
x-axis
wrong?
represent and what does y-axis represent?
It's not a red curve anymore.
Ah, that's
Not
the one, exactly. Because the caption now still says the red curve is a graph of a function. Now, with high contrast on, the red curve is actually blue. So I'm referring to something that, while you can see it without high contrast, which as intended by the original author. Now, if I change my contrast, because otherwise I can't read the caption, I cannot make the connection now between the curve, between the caption and the curve in the actual image. Now, what possible way is there to improve that? Can anybody think of a way how to improve that?
You could say the colored curve.
Sorry, I didn't catch that.
The colored, the curve with the contrast color or something like that, with a bright colored curve.
Right. So that is one way to do it. I think if I understand correctly, that's the way we do it on the next next page, where the caption now still says the red curve, but the red curve is now exactly the same red. So that the two words in red curve now have exactly the same red color as the curve, as the curve in the.
I meant the description could change to the bright colored curve.
No, actually
You
it's
could
changed to
do
the
that
same color
too.
of the curve. So when it high contrast, it reflects the same color.
Right.
The word as well as the graph changes to the same color when you make it high contrast.
Yes, let's try that out. So right now it says, we don't say the bright curve, you're right, but the bright curve, the problem is what is bright? What does that really mean? So you want to make a connection between the words on the curve and the actual color of the curve in the image, right? And the way we do that is by giving those two words, red curve, the same color as we give the curve in the image. So let's see how that performs under high contrast. Let's do the Shift F11 again. Now both have, it still says the red curve, obviously. However, what you now see is that this part, the color of that word is now exactly the same color as the one in the actual image. Now that gives you, well, the red obviously is still wrong, but at least it gives you that connection with the image, so that you can make the relationship between red curve and the curve in the image clear. And obviously that is still not perfect, in particular since you never really know how these high contrast elements work. In particular, and I've showed that to you earlier, if instead of doing high contrast with different colors, I go, say, to a grayscale, just grayscale, then, I mean, there's still no way of actually discerning red curve, because now everything is just black and white, right? So that's quite useless. So anybody has an idea how we could change that? What other possible ways could we now use?
We can describe the nature of the curve.
Yes, how would you describe the nature of the curve?
Like how it looks in visual. So the curve that is passing through X and where it is touching to Y, we can give the description of the curve in short.
Yes, but so that would mean you would describe you would describe the curve in relationship to what else is in the image. Right?
Yes.
So what if I'm an absolute novice in the subject? I have no idea what you mean with the origin, or with the y-axis, or with the x-axis, or anything of that nature. Anything that would kind of take it away out of the. So think about it. You don't want people to be stuck in the same context that they're actually trying to learn. So you try to avoid giving people people having to understand what you're actually trying to teach them in the first place. So it's kind of a chicken and egg problem. It's perfect. It's easy.
Yeah.
Right. The egg comes first. Any other way?
And just say a non-straight line that is there.
It
In that
there
case,
is
yes, I agree. What about if this were just a single constant function?
sorry.
If this so non-straight line means that yes, that's the curve. There's only one curve in that image. What about if that's a straight line as well? Any way how we can get it away from the actual type of line?
One solution would be like, hello?
Yes.
Yeah, one solution would be that we can remove the word red, and then the word curve will only be there. The curve is the graph of a function that, and the curve word is green in color. So by the color, we match that this is the description of the curve, which is green in color. We can use the word red.
Right. Right. Yeah.
We may not probably
But you
use
still
the
were stuck on
colors.
colors. Sorry. Yes.
We don't use colors. We probably use dots and dashes, some other representation for the curve itself.
There you go. That's what I was looking for. There you go. That's on the next page. Here's a Wikipedia. I've stolen two trigonometric functions from Wikipedia. One is a cosine, the other one is a sine. And now the way it's being referenced here is as the graph of two trigonometric functions, sine and cosine. And now the color changes to red. Sine is the red solid curve. Cosine, now we change the color to blue. Cosine is the blue dashed curve. Now we have two different types of references. We have the color reference, right? So we have the word color reference. We have the actual color reference, which changes in line with changing the high contrast. So now, for instance, sine is the red solid curve, changes to a light blue, the color, and the cosine is the blue dashed curve, changes to a yellow. Same in the graphics, but in addition, we also have solid versus dashed. So if we have a monochromatic user who reads that, can still make out the differences by just looking at the patterns of them.
Volker, why do you have to add red and blue?
Excuse me?
Why do we need to add red and blue? We can't just say solid and dashed.
Yeah, I used to felt
yes.
that. Yeah.
Yes, absolutely. Yes. That would still be all right. And the color reference would still be there indirectly by just kind of doing the color. Why do we add it? Because let's face it, the majority of users will not even recognize that this could potentially be a problem because they never use a dark mode. They might never use it, you know, they might never change the contrast, and therefore they still kind of are used from their upbringing to referencing by color. But in many ways, so you want to cater for that audience, but you also want to cater for the audience who doesn't really have a track with color or will change the color palette in the background. Now, one ideal scenario, which unfortunately I'll tell you that it's not possible, is that you actually, and I have to admit, I tried that some time ago at a hackathon where we were trying to, or where I was trying to actually be able to understand what the color in the actual image is, so you can change the word for the color in the caption. Why is that not possible? Because that's just a security issue. So you do not get to the actual client side or the actual color that is being displayed in the browser. Obviously, you know, if you have a visual impairment, you don't want to disclose it. Obviously, then you don't want people to notice how that you change the background color, and therefore you can also not. There's no way of reading that from the client. So there's no, you know, ideal solution for that problem. But there's a number of ways around it, and that's one of them. Right. Now, I'm mindful of the time, and I wanted to get through so much more already before the break. But let's just go through some of the WCAG criteria now, and we can pick up after the break with a few more. So one important part is, of course, that a website or any web document should be operable. That means that everything should be reachable not just with a mouse, but also with a keyboard or with other functionalities like with gestures on your mobile phone. It shouldn't be operable to the. It should be operable also means that it should not impair somebody who might not be able, for instance, to look at certain content. A classic example is there shouldn't be more than 3 flashes at a time in a particular threshold that is normally aimed at people who might be getting particular epileptic fits, for instance, if they watch too much flashing material. There's a couple of other things that are very important. That pages should be titled. That means if I go to a page and I have to listen to what the page is, that I at least get a meaningful description of what I see, rather than just a URL being spoken out, which can be very, very long and very, very uninformative. And it should be, everything should be focusable, meaning that there shouldn't be, say, links somewhere in an ad on the right or somewhere which is not reachable by keyboard, and so on and so forth. We'll look at some of these things in more detail later after the break. Another one is success criteria number 3, that's understandable. So we're now down to poor. P was perceivable, O was operable, U was understandable. That is primarily, is it understandable for the audience it's aimed at? And that's generally guaranteed by at least putting in the basic language of the document. That's normally the metadata, which is at the start of the document saying this is an English web page, or this is a Hindi web page, or this is a German web page. And the final one is POUR. R stands for robust. Robustness in that case means, well, how does error handling work on a website? Are there any traps, for instance, keyboard traps? If you have a user operating a website with keyboard only, is there a possibility they end up somewhere in the site where they never ever get out of? Unfortunately, that happens a lot, where people just assume that you then can click with a mouse somewhere else. Some people can't. Another question of robustness is obviously, does it work everywhere, or does it use portable standards? And in particular, the worst thing for robustness, or when you can see immediately that a website that violates the WCAG implementation principles, is when it says this page is best viewed with browser X on operating system Y. That's generally the worst that you can do, right? That used to be kind of a standard thing. This page is best viewed with Internet Explorer on Windows 7. Used to be a standard saying, and that's really, really poor. Right. We'll talk a bit about the full web stack after the break. I'm mindful of the time. Instead, I'm going to give you a quick idea of what we're going to do after the break. And that is, we're trying to our hand at evaluating accessibility. So we want to play with a couple of tools that allow us to evaluate a website. I've put together an example site for which I want you to find problems. I'll just show you briefly how you can evaluate websites in general and how you can do that. And unfortunately, there's a lot of tools out there that help you evaluate a website or evaluate a web document for its accessibility. None of them is perfect, obviously. There's still a lot of manual work you have to do, but there's quite a number of good ones. And we're going to look at some free tools, which are primarily extensions for your browser, or at least for web browsers, after the break. There's a couple of full tools, which are all proprietary, particular from DQ is an X tool, and from Tenon is a tool which you can use at least partially on the website, and let's do that. Excuse me. Right.
See, somebody please mute yourself. Somebody has unmuted.
Right. Let's have a website at. So I'm looking at the University of Birmingham website, for instance, and you can say, okay, test this website. So that's just a URL which you can enter, and then you test the website. and it's running a test, and it actually goes quite fast normally. Obviously, when I demonstrate it, it doesn't. And it shows me it's got 29 accessibility issues, 3 real errors, and you can view the details of what goes wrong. So there's invalid hypertext references, form fields occur after the forms, and there's unstructured headings. We'll see that. What this means after. We see that afterwards. What's the IIT webpage? What is the, is it IIT?
iitd.ac.in. www.iitd.ac.in.
Let's see what happens here. Just as comparison, let's have a look at what goes on here. And so I'm looking at the website right now directly. So there's a lot of animation that comes up before the website even comes up. It's still running tests, so that's probably not a good sign.
There is a lighter version.
Is there a light? Whoa, welcome to the new website. Let's go. Right. I see what Tenon says. Well, it's still running tests, which is doesn't. Well, we can look back later whether that's any positive answer. But these animations beforehand, it's normally not some. An error occurred testing, so they can't even be tested for accessibility. That's well, we can try later again. Anyway. That still doesn't mean, just because it tests for accessibility still doesn't mean that it's usable. I've put up the old joke of, it's an old XKCD joke about what people expect from a website from the university and what the university, in particular the university administration, often gives you. So what you normally find on a university website are things like a campus slideshow, the alumni in the news, what's the latest from the chancellor. What people normally come to look for are information on their courses, the phone numbers of the faculty they want to talk to, etc. So the Venn diagram then generally just tells you, well, the only thing that people agree on what's really there on the website is the full name of the school, which is, if we extrapolate that to what usability on the web is in general, that's a very similar picture. There's 3 different types of concerns. One is the designer who wants everything intuitive and pretty. One is the developer who wants everything efficient and fast. And finally, there's the marketing aspect who wants people to, or the user experience researcher who wants everybody to be satisfied. And then the usability is just this tiny little sweet spot in the middle. And that's exactly what we're going to aim for in the rest of the lecture. And we'll do that after the break. And while the intermission is, I have a couple of tools which I would like you to install. They are all extensions of your browser. If you could install those during the break, we'll reconvene in 5 minutes, and then we'll start playing with some of those. And if you have any questions on them, I'll be back in a minute, and in case you have questions on installations.
Sir, I have a question.